Morning Year 4, hope you're all doing okay and welcome to Tuesday's maths lesson on fractions. So before we go into it, can you have a go at the starter for me? It says, can you order these fractions from smallest to largest? So before you compare them and look at which one's the smallest, which one's the largest, you need to make all the denominators the same because you cannot compare fractions unless their denominator is the same. So we have 3, 12 and 4. See if you can spot the relationship between those numbers and see if you can make all the denominators the same first, and then you'll be able to compare them to see which one's the biggest and which one's the smallest. If you're not sure, then stay with me and we'll go through it together. So as I said, we've got 3, 12 and 4 as our denominator. Now straight away I spotted that if you times 3 by 4 you'll get 12, and 4 times 3 is 12. So they're both, 3 and 4 are both in the 12 times table. So therefore I'm just going to times these ones by something to get 12. Okay, so we're going to keep this one the same, but this one, remember I said to get from 4 to 12, you times it by 3. So therefore times the numerator and denominator by 3. So 2 times 3 is 6. 4 times 3 is 8. Not 8. 12. So there we got, so that's the equivalent, it's 6/12. And then for this one, to get from 3 to 12, you can times it by 4. So therefore we're going to times it out by 4. So 2 times 4 is 8, and then 3 times 4 is 12. So we have 8/12, 4/12 and 6/12. So therefore, if you were ordering them from largest to smallest, it would be 4/12 first, and then it would be 6/12 or 2 quarters, and then it would be 8/12 or 2/3. Okay, so hopefully you managed to get the same. If you didn't convert them back, then don't worry too much because they're still equivalent, but hopefully that was okay. So today then we're carrying on with adding fractions with the same denominator. We're just looking at word problems today and more problem solving questions using our knowledge from yesterday. So hopefully it should be quite straightforward. So we have the same star words as yesterday. We will be looking at improper and mixed fractions again. But yeah, other than that, they're all the same really. So our first question today then says, Ferdinand the bull eats 2/3 of a bale of hay on Monday and 2/3 of a bale of hay on Tuesday. What fraction does Ferdinand eat altogether? So before we think about how we're going to work out, what are the important words in this problem? So if you can pause the video and do so and see if you can have a think about what the most important words are. So straight away, we've got two fractions here. So we've got 2/3 and another 2/3. And then it says, what fraction does Ferdinand eat all together? So we know that all together normally means we have to add them together. Okay, so that means to work out, we would need to do 2/3 add 2/3, because it says he ate 2/3 on Monday and 2/3 on Tuesday. And if you want to know how much he ate all together on Monday and Tuesday, you need to add it together. So this should be quite simple. Remember, we keep the denominator the same, so we got 3 and 3, and then you add the numerator. So 2 add 2 would be 4. So therefore, he has eaten 4/3, or you can write that as a mixed number fraction, which would be 1 and 1/3. I feel like I whizzed through that quite quickly, but I hope that's quite straightforward. It's the same concept as yesterday, where we're adding. You keep the denominator the same, and you just add the numerator. And then I've just converted it from an improper fraction to a mixed number fraction. I am going to get you to have a go now. Oh, before we go on to that though, we could use a fraction bar to work out as well. So if you prefer to have like a visual, then that might be better for you. So you can see here we've got 1 whole of, or 3/3 and then 3/3, because they're, I'm going to break them up into 2 shapes because we know the fractions are thirds. So we know that he eats 2/3 on Monday. So let me get another colour. So he eats this and this on Tuesday, but then he eats another 2/3 on Tuesday. So then he eats this and this. And then you can count them all. So we've got 1, 2, 3, 4 thirds. And you can also see it's 1 whole and then 1 extra third as well. Okay, so that's how you could use a fraction bar. It's just might be easier for you if you're able to see it, as opposed to the abstract method, which is what I just showed you here, where you just add them. But you can use whichever one. It's up to you which one you prefer. You can use as long as you get the right answer. I'm not too concerned really. So now I want you to have a go. So you can use the fraction bar method if you'd like to, or you can just add them up. It's up to you using the abstract method. So the question says Emma runs 5/8 kilometers. She has a rest and then runs a further 4/8 kilometers. How far has she ran? So what you need to do is add these two together to find out how far she has ran altogether. So you can use a fraction strip, sorry, I can't think of the right word then, or you could just add them. It's up to you. Okay, so pause the video, have a go, and then I'll go through it with you afterwards. Okay, let's go through it together then. So all I've done so far using this fraction strip is split it up into one whole, because we know the fractions we're looking at are eighths. So I just counted 1, 2, 3, 4, 5, 6, 7, 8. So that is the equivalent to a whole, and I just put a box around it. So she runs 5/8. So let's colour in 5/8. I'll use a different colour. Let's use blue. So 1, because remember these are all 1/8. And if she ran 5, we're going to do 5, 1, 2, 3, 4, 5. She has a rest and then runs a further 4/8. So then we do 1, 2, 3, 4. So now you can just add them all together. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore she ran 9/8 kilometers as an improper fraction. You can also write it as a mixed number fraction. So look at how many wholes she's ran. She's ran one whole, so one lot of 8/8, and then there's one left over. So one whole and 1/8. Equally, you could have just added them. So you could have done 5/8 and 4/8, which equals 9/8. So you get the same answer. It's whatever method you prefer. So let's move on then to our developed learning. So this is where we look at our kind of more problem solving questions. So I have 17 sevenths and I have 3 fractions which are added together to make that. However, we've only been given the numerator of one of those fractions. So it says, look at the question, how could we find out the missing numerators? That doesn't make sense. What do we need to know, it should say. Let's change that. So have a think, pause the video and work out what we need to do to find out these two missing numerators. If you want to have a go at it, then feel free and pause the video. If not, then I'll go through it with you now. So straight away, I can see that we've got 17 sevenths. That's our answer. So we know that this 5 add something is going to equal 17. So what I'm going to do is take away 5 from 17. So 17 take away 5. Let's get a pen. 17 take away 5 would be 12. 12 sevenths. And then we've still got, so all I've done is taken that out and taken it away from there. So we don't need to worry about that anymore because I've just taken it away from there to work out these two. So now we just need to find two numbers that are going to add to make 12. So we could do 6 and 6. We could do, my pen, 10, 2. You could do any two numbers that would add up to 12 and it would still be right. So let's use that example for the minute. So we have 10 sevenths, add 2 sevenths, and then we got to add this one again to just check it works. So 10 add 2 is 12, add 5, 13, 14, 15, 16, 17, 17 sevenths. Okay, so you can always check at the end just to check it works as well. So that's just using your problem solving skills. But hopefully it was quite straightforward for you. So now it's time for you to have a go at your questions. There's 2 for group 1, then there's 1 for group 1 and 2, and then a couple for group 2 as well, and a challenge of course. So this is group 1's question. I'll just make it a bit bigger. So if you're doing group 1, this is your first question. If you're doing group 1, this is your second question. Now This is for group 1 and 2. And this is for group 2. Now I need to make this a bit smaller. I'll make this one smaller in a minute. Just because there's a number line at the bottom of that might be useful. So those are your 2 questions for group 2. And then this is your challenge. So have a go at those, and then at the end we'll go through the answers. Okay, hopefully you managed to have a go at those questions. It's time to go through the answers. So if you did group 1, we'll go through group 1 first. So it says Tino the horse eats 4/5 of a bale of hay on Monday. He eats 2/5 of a bale of hay on Tuesday. What fraction does Tino eat altogether? So this is very similar to the question we looked at the beginning of the lesson. You just had to add 4/5 and 2/5, and it actually has the fraction bar or the number line there to show you. So we have 1, 2, 3, 4/5, and then 1, 2. So you could have counted them to find out the answer. 1, 2, 3, 4, 5, 6, or you could have added them as well. So 4/5 add 2/5. Now they want it in a mixed number fraction. So as an improper fraction, it would be 6/5. But we can see here, if this is 1 whole and it's 1 extra, we know it's going to be 1 whole and 1/5 extra. You can actually see it there because it goes up to that point, which is 1 whole and 1/5. That was number 1. If you did number 2, it says Alexis runs 7/9 kilometers. She has a rest and then runs a further 5/9 kilometers. How far does Alexis run in total? So they haven't actually shaded the number line in for you this time, so you had to do it. So if you drew it in your book, then that's great, or if you just added them, then that's fine. And this time they actually want it as an improper fraction, which is where you have the numerator as a larger number than the denominator. So I'll colour in 7/9. So that's 7/9, and then she runs a further 5/9. So I'll add another 5 on. 1, 2, 3, 4, 5. So 7/9 add 5/9 is 12/9. So Alexis runs 12/9 in total. Okay, group 1 and 2 then. You had to work these out and give your answers in improper fractions. So the first one would have been 6/4. B would have been 6/10. This one would have been 16/12 or 16/12. D, 3 add 1 add 9 would be 13, so 13/10. This one, the denominator is 5, and your numerator would have been 9. And then 8/9, which is written like this, and 5/9 would be 13/9. Okay, so hopefully you got all of those correct. So group 2 then, match the calculation to the correct answer. So we have, I'm just going to work out the answers and then we can match them up at the end. So 6/7 add 3/7 would be 9/7. This one, 5 add 1 add 6 is 12, so that would be 12/7. This one would be 7/7, and this one would be 11/7. So straight away I can see that we've got 11/7, that must be that one. 7/7 you should know is equivalent to 1 whole, so therefore that's going to be the same as that one. And then we have 12/7, and I can see that down here, which means that 9/7 must be 1 whole and 2/7. You may have also used the number line at the bottom to help, and that's fine. 5, Fred works out this calculation. 3/8 add 7/8 equals 10/16. What mistake has Fred made? So Fred has added the denominators, which he didn't need to do. You just need to add the numerators when the denominator is the same. So the correct answer would have been 10/8. Okay, so hopefully that was quite straightforward for you. And then finally, the challenge. This is where you had to use kind of your problem solving skills to work out. So I'll pause the video, I'll write the answers down, and then you can check whether you got them correct. Okay, so I've written all the answers down for you. We'll go through A and B first. So A, you should have had 4/5 add 3/5. The second part, 4/5 add 3/5 again, because 7/5 is actually equivalent to 1 and 2/5, so it would have been the same. And then the last one would have been 4/5 add 4/5. Part B, 11/13 add 6/13, and then 7/8 add 4/8, and 5/6 add 1/6 equals 1 whole. If I did get any of those wrong, please let me know. Like I said, I do get things wrong every now and then, so let me know if they are wrong, because I did quickly rush through them, if I'm honest. So C, this one, you might not have these answers, and that's fine, because you can put any two numbers in there. That would have added up to 12, because I just did 15 take away 3 to work out what was remaining, to know that these two had to add to that number. So 15 take away 3 is 12, and then I just thought of two numbers that added to make 12, and I just thought of 6. So as long as these two add to 12, then it'll be correct. This one, you had to have two numbers that added to 10, because 15 take away 5 would be 10. This one, any two numbers that add to 11, and then this one, two numbers that added to 9. Hopefully that all makes sense. This is quite a tricky question, so don't worry if you struggled with it. And if you do want to go through it again, then please let me know, and I can always add you to my drop-in session on a Wednesday to go through it in a bit more depth. Okay. Also, just want to say, I've only just noticed that the date on my previous video on Monday, I put 2020, and yeah, I've only just noticed, so I apologise for that. But thank you for watching this video, and yeah, hope it wasn't too bad for you.